In section 5.7, we return to the idea of rectilinear motion, but now from the integral perspective. So let's first of all take a look at an example that reminds us of where we've been so far with this. And let's suppose that a position function is given by s of t is equal to 2t to the third minus 9t squared plus 12. And let's find the position, velocity, speed, and acceleration at time t is equal to 1. All right, well, let's see. Just do it for an arbitrary t to start with. The position function is 2t to the third minus 9t squared plus 12. The velocity is the derivative of the position function, so that's going to be 6t squared minus 18t. And the acceleration function is the derivative of the velocity function, so that's going to be 12t minus 18. At time t is equal to 1, well, if t is equal to 1, this becomes 2 minus 9 plus 12. So 2 plus 12 is 14, minus 9 is 5. So the position would be 5. The velocity, well, this will be 6 minus 18, would be negative 12. Okay, so the velocity will be negative 12, and the acceleration will be 12 times 1 minus 18, negative 6. Notice since the sign of velocity and acceleration are the same, this would be speeding up. The speed at time t is equal to 1 is the absolute value of the velocity at t is equal to 1. And so that would be the absolute value of negative 12, which is 12. So this would be the speed at that time. So remember how this works. The derivative of position is velocity, derivative of velocity is acceleration. The absolute value of velocity is speed, and when the signs on the velocity and acceleration are the same, we're speeding up. When they're opposite, we're slowing down. Okay, all right, well, now let's go in the reverse order. Let's suppose that we know the acceleration, and we know that the velocity at time t is equal to 4 is 1, and the position at time t is equal to 4 is negative 5. Let's find the position, velocity, and speed functions. Well, to go from, remember the acceleration is the derivative of velocity, so that tells us that velocity is an antiderivative of acceleration. So to get the velocity function, we'll anti-differentiate the acceleration t squared dt, and let's see, that's going to be t to the third over 3 plus some constant. I'll call it c1 because there's going to be another constant coming along here, some constant of integration. All right, now to determine this constant of integration, I have this condition. The velocity at time 4 I know to be 1 because I'm told that, and the velocity at time 4 is going to be this velocity function with every instance of t replaced by 4, so that's going to be 4 to the third divided by 3 plus c1. All right, avoiding the middleman, v of 4, we have 1 is equal to, well, 4 to the third is 64, so we have 64 thirds plus c1, so c1 is going to be 1 minus 64 over 3, and that would be 3 over 3 minus 64 over 3, which would be a negative 61 over 3. So now I know the velocity function precisely. V of t is equal to t to the third over 3 plus a negative 61 thirds or minus 61 over 3. And there's our velocity function. Okay, and I think I have this on the next one. All right, just the velocity function so that I'm sure I got it right. Okay, and now we want to find the speed. Well, the velocity function was t to the third over 3 minus 61 thirds the speed function is the absolute value of the velocity function. So that's going to be the absolute value of t to the third over 3 minus 61 thirds. And here would be the speed function. So that would be the speed function. Okay, and there we have it. All right, now the position function, remember the derivative of the position function is the velocity function. So that tells us that the position function is an antiderivative of the velocity function. All right, and so the position function is going to be an antiderivative of, what do we have? What was it? It was t to the third over 3 minus 61 thirds and if I anti-differentiate that with respect to t, well, I'll get t to the fourth over 3 times 4 over 12 minus 61 over 3 times t, all right, plus a constant of integration. I'll call this one C2 so we don't confuse it with the constant that we had in the last integration. And we have now that the position at time t equals 4 is negative 5. So negative 5 is equal to this position, is a position function evaluated at time t is equal to 4, but that's equal to this expression with every instance of t replaced by a 4. So that would be 4 to the fourth over 12 minus 61 over 3 times 4 plus C2. Eliminating the middle guy, this S of 4, I have negative 5 is equal to, well, I can cancel one of the 4's with the 12, and that'll leave me with a 3 in the denominator and 4 to the third in the numerator. That's going to be 64 over 3, all right, and 4 times 61 over 3, well, that's going to be 244 over 3 plus C2. And so let's see, subtracting, I get negative 5 is equal to, all right, this would be a negative 180 over 3 plus C2. 180 divided by 3 is 60, so this would be negative 55 is equal to negative 60 plus C2. That means that C2 is equal to 60 minus 5, or C2 is equal to 55. And so we have then that S of t is equal to t to the fourth over 12 minus 61t over 3 plus C2, which is 55. And I think that we'll see that that's the case right here. Okay? All right, we'll do some more examples in the next video.